Hello and welcome back to Nature of Code in Rust and GGEZ exercise 2.7. So this is continuing on with the fluid resistance. For this exercise, fluid resistance does not only work opposite to the velocity vector, but also perpendicular to it. This is known as lift-inducing drag and will cause an airplane with an angled wing to rise in altitude. Try creating a simulation of lift. Well, I can tell you right off the bat that this simulation is not gonna be like ultra realistic. I know there's a lot of complexity with like wings and wing shape and the movement of air over the wing, and that causing lift. But I think what we're gonna do is we're gonna create a simple rectangle and then have an angle on it. And then based upon if the angle is like positive or negative, we'll have a lift essentially pulling upwards or a lift pulling downwards on a rectangle. So let's go take a look at our code. What we have is where we left off with exercise 2.6. So if we run cargo.run, we have the same thing we had previously. So we do have those rectangles showing, but besides that, a lot of this is gonna have to go. So let's clean house here in main. So first of all, we're gonna have just a singular mover again. So just a mover. For gravity, gravity's gonna be fine. Water, well, I actually want to change this. This is now gonna be the sky, but that's still a zone. So that should be fine still. For our main state, we're not going to need a random number generator anymore. So don't need you. We need our width and height. We don't need the space between or this movers. We still need the gravity. You're going to become the sky. Create a new zone. Okay, so I actually want this to begin at 0, 0. So it's going to be the entire screen. Width and the full height. Then our color, yeah, the same blue is going to be fine. And then we're going to have a coefficient of drag on it. I'm actually going to come in here to zones where we have coefficient of drag. I'm actually just going to rename this to drag. And then we're going to have another one of lift, which is also an F32. You're going to get lift here, and we'll just store away lift. Okay, so let's just create lift, which we'll just make it up. We can make it the same as drag for right now and just sort of go with it so wherever we can find it. All right. Okay, so that gives us the sky. We don't need any of this because we're going to create a new mover, just a singular mover. And we don't need our for loop. For our mover, let's make sure that we start this at near, let's see, how do we want to do this? Let's start it at the, we can start at the middle or like near the left edge maybe. So like 50 from the left. And then our Y can be, let's put it halfway down. This is gonna be our height divided by 2. Mass, right, we have to give it a mass. Let's just give it 1.0 for right now. I think we're gonna divorce the size from the mass in this. Okay, so we're gonna have mover, and then instead of water, we'll have the sky. All right, so that's fine. Don't need these anymore. All right, continuing on down. In update, we're having this entire for mover and self.movers. We don't need that for loop anymore. And then wherever we have mover, that's actually going to be self.movers. mover. Okay, so we grab the gravity, we grab a new gravity, we multiply it by self dot. Self dot move. Oh, we missed that. Hold on. Okay, so where we have mover, we're gonna do self dot. There we go. So self dot mover to mass, we get to gravity, we apply gravity as a force. If the mover is inside of the zone, so that's self dot sky. Then we're going to apply drag, and we're also going to want to apply a lift. Now, this drag is probably going to be really, really, really light. So let's just go ahead and add that there. In fact, we're probably not going to try apply drag at all. I know. Just going to remove that. The reason why I'm going to remove that is because this would probably be dragged to the like from the front, right? Like it would be moving forwards essentially, like as it rockets through the sky. So we're just not gonna do a drag. We're gonna have a lift instead. Okay. And like maybe I don't need this lift. Maybe it is just a single drag here. I hadn't really thought about that before. Let's see. Because like I would imagine that air is pretty thick. As the plane moves through it, there will be drag against it, but we're not going to simulate that really. We're just going to simulate the up and down movement. So we're probably going to do something like self dot mover dot apply, instead of drag, it'll be like apply lift with self dot sky. Of course, it doesn't like that, but let's not worry about that right now. They're going to have our update and check edges. Okay, so then in draw, so I realized in order to get the rotation properly, we're going to have add a rotation to the draw params, but this singular draw param is across all of these. So we're just going to have to get rid of this mesh builder, and then for each of our things, it'll just do its own mesh and draw it. It'll be fine. We're not doing anything crazy that requires multiple draws here. So here we're going to do mover.draw, and we're going to handle the context. And then we'll do, this is going to be self.mover.draw, self.sky.draw, and this also, we're going to hand the context. Let's go ahead and we're going to question mark because it will return a game result as well, because we're going to have it build the mesh and draw it inside. So that's what we're going to end up doing. Okay, so that's all of those things. Don't need you anymore. Let's go ahead and let's make sure we're drawing things first appropriately. So we can create and apply lift. Let's head over into our mover. I'm going to just have this not do anything yet. Pub function, apply lift. We're going to take in the zone and just do nothing right this second. Okay, so that's happy there. And then we need to update the draw for the mover and the zone. So this takes in a context. And we're going to return a game result. Okay, so this is the bounds. So this is fine for that. But then we have to create a new mesh. It's going to be let our mesh equals mesh builder new. Then we build it with the context. And then we're going to do a graphics draw. Context, a reference to the mesh, and then the draw params. We're eventually going to want to have a rotation in here, but let's not worry about that. And then we're just going to return this, which is the game result. Okay, zone, right, this is now just the drag. And we don't need this mesh. Okay. Next up, we have to head into, let's see, back to the main library. It's now the skies draw's turn. So we're taking in the context. And we're going to return a game result. Okay, let our mesh equals builder new, create this rectangle. Oh, not borrow it, build it. And then graphics, draw it. Okay, so we have one warning, unused variable zone. Okay, so this is just the apply lift. We're not doing anything with that. So let's make sure that this is like looking right. Okay, so we do have, it's sort of barely visible. Here's our mover. Let's go ahead and make sure that the mover's width is, maybe we can do something like mass times like 100. So it's nice and wide. There we go. Okay, so this is our very rudimentary plane. Now it's bouncing when it hits the bottom. I kind like, if it hits the bottom, we should probably just have it crash, right? So in handle edges or in check edges, let's if it reaches the bottom of the screen, which is right here, we're just gonna say self dot velocity times equals 0. So we're gonna reset our velocity. And that's it. Like then there won't be any movement anymore. It's just gone. It's probably slightly underneath. Okay, so I think that's good. Let's see. Then we want to have a rotation for this. Okay, so let's do it like a handle input, so we can have a rotation. So what's that gonna be? That's gonna be like a pub function, handle input. We're gonna take in a context. I don't know if we need to return anything. So what we need to do is figure out what key is pressed. So I think we can do, let's see, GGEZ input keyboard pressed keys. Give it a context. Okay, that's going to return, a hash set with a virtual key code and a random state. Whatever that is. Let's go ahead and actually just match off of this and see what we get. Okay, so I don't think we can do that. Let keys equals, because it's, okay, it's a hash set of the virtual key codes. So we should be able to loop through this. So for something in keys, what are you? Okay, we got the key code. So we have the key code, which means we can match these. So match key code, fill the match arms. Here's all the possible keys that we could press. And we're pretty much only going to be concerned about left and right. So here's left. Here's right. Okay. So everything else, I'm going to replace with an underscore. So that, and then all of you, including you. we're going to do an underscore, so a catch-all, and we'll just do nothing. Now for left and right, we need a rotation in here. So we need a rotation, which is an F32, and then let's also have a rotate by, or rotate like amount, which is going to be F32. So like when we're holding down left or right, this is what it's going to be incrementing or decrementing this by. So a rotation, we're going to set this to just 0.0. And rotate amount is going to be, let's do like 0.01 and sort of see how this feels. And then down in here, we can then say, okay, if we're left, self.rotation minus equals self.rotate amount. And here, self.rotation plus equals self.rotate amounts. Okay, so you also have something else, an unknown. So I don't really care about that. Mismatch types, expected. Oh, I guess there's no enum. It is just the key code. Okay, perfect. So let's go ahead and in draw, we're going to give this draw param rotation of self.rotation. Everything should still be fine, so we should now handle this input. Let's do it right away. So self.mover.handle input, handle that context. And now we should be able to run this and rotate this around like that. Now it's a little bit weird because the rotation is off center. We'd have to draw everything by the center. I don't actually think that's necessarily a problem. I wonder if we can do like an offset. We can do an offset with, what do you need? Okay, it's a point. So we need half of our bounds. I think like with half of our width and height, I think. So let set equals, this wants to be just an array, so it's going to be our self.width divided by 2. Self.height divided by 2. Let's see if this likes our offset. Or if we need to reverse that. Not exactly what we were going for. What if this is like negative? That feels like it didn't really do anything for it. So like I have this draw offset, but yeah, I kind of feel like our rotation, unless the offset needs to happen before the rotation. I feel like that's not really doing anything for us. I can even do like maybe negative self.width, self.height, but I'm thinking we'll just have to create our bounds and draw it based upon the center. Yeah, I feel like that's not really doing anything here. Set the transformation. Oh, I think this is if we're doing a transform. I wonder if we can. Okay, so I think what we want to do is, in order to have this work, we're going to need our mover to create and store a mesh of what it looks like here. So we need a mesh. they're going to be a mesh. In order to create the mesh, we need a context coming in here. So our mesh is going to be equal to a mesh builder. New, I'm going to create a rectangle. Draw mode, fill. For our bounds, it's going to be a brand new rect. Okay, so we're going to give it this X and Y, and then the width and a height. So what I want to do is have the center of our mesh be in the like the 0, 0 essentially. So for X, I'm going to do negative width divided by 2. And then our Y is going to be negative height divided by 2. Then our width and height. So width and height. For our color, we can just make this white. It'll be fine. And then we're going to build this context. We're going to have to return a game result. So not just self anymore, but a game result with a self inside. Then this will have to be wrapped with an OK. And we'll store this mesh away. Then down here in draw, so we don't have to create this bounds anymore. In fact, we don't have to create the offset. We have this mesh already, so we don't have to create that. Instead, all we have to do is draw it. So we're going to do a graphics draw, hand it a reference to self.mesh. No offset here. And then we give it this rotation. Now, I can't run this right away because we got some errors, because we're now requiring to pass in context at this point in time. But we do have this. So when we create our mover, we also need to pass in context. And then we're going to question mark to get our mover. It actually doesn't say there's any errors. Let's see if this works. Okay, there is our mesh over there in the top left. So we're also going to want to in draw set a destination for this. So destination of self.location. Is there like as an array? Let's give it just something. The Y we want to keep. Actually, in this vector, what do we have to like make it something that works? As mint 0.2. That's what we want. So self.location.as mint 0.2. Okay, here it is. And now it rotates the way we want it to. And so it's syncing through the floor. Perfect. We probably want like a flag where like is alive or like maybe crashed. We're gonna have this be a Boolean. Say self.crashed equals false to begin with. Crashed. And then in update, we want to update this only if we're not crashed. So if not self.crashed, then go ahead and do all of these things. And then when we check edges, if our Y has hit the top bottom of the screen, self.crashed equals true. So this way, we should just stop moving down as soon as we hit the floor. There we go. We can still like go left and right, but that's not a problem. Okay, so we got our movement going. Next thing that we need to do is we need to be able to fly forward in order to give us forward momentum, because And as I was thinking through this, our lift induced drag is going to be based upon the velocity forward and not anything else really. So we need to give ourselves a good velocity forward. What would that look like? Let's do new. Like our fly force. Like we already have this gravity. We need, okay, so fly force. I guess this is just going to be a speed, right? So let's bring in speed, which is going to be an F32 here. And we're going to have a fly force, which is going to be a vector 2. So our x is going to be equal to the speed, and then our y is 0, 0. So this is going to be moving forward for us. And we're going to store this away. What this means, though, is that we're going to need like a constant flying forward. So let's just give this, I don't know, 0.5. Let's just see what that feels like. Let's see, that's our speed. That should be happy there. We don't have a fly, do we? To like apply this force. So let's add a function for this. So pub function fly self. We're just going to self dot apply force, self dot apply force. And so in the main library, after we handle the input, let's just make our mover fly. Okay, so that's flying pretty fast forward, but I think that's fine. We may want to slow that down a bit. Let's try like 0.01. That is indeed pretty slow. But I think that's gonna be fine because we're going to want to sort of keep it on the screen for at least a little bit of time. So we crashed before we got to the end of the screen. So now we're going to want to have lift applied to it. So lift is pretty much the same as drag as far as I can tell, or at least from what this from what this challenge states, that seems to be what it is. We're finally going to do an apply lift here. So we have this zone. I think what we're going to do is copy this apply drag, and we're going to start there. So let's rename this. Instead of drag, you're going to be lift. Zone is just the drag. Okay, so lift equals the self.velocity, magnitude. Okay, so we're going to figure out what this lift is based upon our speed. And I think that should be fine. Now, we don't need this self.width thing anymore. I think that's going to throw things off. Then we create our drag force from the velocity. We normalize it. I don't think we want to reverse this. We're going to multiply the lift. You know what we want? We need a perpendicular because it's to the perpendicular. So that's why it's not reversed. So let's create a function to create those. So pub function. Let's see. Let's perpendicular left. Take set. We're going to return a brand new self. So self. Okay, so I think what it is wait, I know that it's like the reverse this way. So y self.x like this. And then I think, so if we're moving it to the left, the y I think is reversed. If we do right, it's the opposite. We're going to do a self. X is going to be self.y, and then y is going to be negative self.x. I want to say that that's what it is. We'll probably find out really quickly if it's wrong. So I want perpendicular left here to get this vector. We normalize it, we multiply it by the lift, and then we add this in. So this is the lift force. Okay, so this is applying the lift. This is just like always applying the lift for us, and we have that here. Let's just see what happens. And it's gone. Okay, so what happened? It's not showing anything at all. Let's see, I wonder, I'm actually curious whether or not we have a problem due to our mover having NaN as like anything, like something in it. So let's do a debug of our self.mover. We just have to do a reference to it. That does mean we need to come up here and derive debug. And then once we run this, I also moved us down to like 1 per second. Okay, so our vector 2, our fly force is set. We're not crashed. Oh, look at this. Okay, a velocity is not a number. So what's going on here? We are in, it must be happening in apply lift. So we're getting a magnitude and normalize. Normalize and magnitude are the two things that I think could cause problems. Let's actually move this debug and move our debug into here. So I have a theory that our debug is, we can do lift force here, and then right after normalize. I think it's the normalize. Yeah, there it is. So our lift force starts negative 0 and 0, and then it's NaN after we normalize. So there's a problem there. Now normalize, we're doing, divide by magnitude. We're starting with a velocity of 0. So let's see, magnitude, we get, I think this would be 0, right? So we need to check to see if, let magnitude equals self.magnitude. If magnitude is 0, then we want to return, we don't want to actually do anything. So if it's not 0, then go ahead and do this. And let's try this again. Oh, that was not happy. Let's do that. Okay, no errors, no warnings. There we go. Okay, we're still seeing here, I can still rotate up and down. And then I'm looking here, our X is negative, meaning that our lift force is actually it's a negative X. Okay. Our X should definitely be positive. So I think I have reversed this a little bit. So in perpendicular left, I think it's the x negative self dot y, and the y is self dot x. So if we imagine that we have like a line horizontal like this, so the x is 1 and the y is 0. And then we want to go this way, like up. So that's rotating this way. Our x becomes 0. And then the y becomes a negative. Okay, so the perpendicular, okay, that is what this is. So negative self dot x, negative self dot y, then the x is self dot y and negative self dot x. I think that's correct. So we create a perpendicular left. Oh, wait, we're not reversing. Let's make sure we're multiplying by our lift. All right, let's try this again. So it's a very small x. We're still at 1 frame per second, so let's bring it back up to 60 and double check how this is just sort of looking at. Okay, that's fine. So it's flying down like that way. We need a stronger lift. So let's pull drag up a little bit. Oh, look at that. Okay, so the drag moved it left. Now we're not applying drag at all. We're only applying lift. So let's try, if I move perpendicular right, maybe I have reversed that. That did feel like it's trying to take off. Let's reduce our gravity down by just a smidge. So in our main library, here's our gravity. Let's bring that down to there. And okay, it starts flying. All right, so that tells me I need to just reverse these. I think this is like that, and you are like that, which means we're back to perpendicular left. And we should still be where we were in the last time we ran this. All right, perfect. And then we can still rotate like this. And so what we want to do is we only want to apply this lift if our rotation is let's see, less than 0. How about like equal or less than 0? So if self.rotation is less than or equal to 0.0, then it's kind of just do all this stuff, right? Oh, and we want to normalize before then. Okay, so I think this will now apply our lift. If we're, so this brings our lift up, and then that drops us back down again. So if I reduce our forward momentum by just a little bit, or we make the entire screen longer, that's another possibility. Let's fly force. You are, oh, the speed coming in, your speed is 0.01. We might need to like change the drag because there's like, does the fly force matter? we crashed. I think it does. Oh, right, because our drag now has to be lower like that to increase lift because our forward velocity is lower. So we fall down. We apparently go way crazy fast up. Maybe that's, I'd rather drop that down and drop gravity a lot more down. Okay, so we fall. When we're pointed down, do we fall? Okay, this is going up. And then this is rotating more than 0. Gravity is just a little bit too weak now. Let's take one of these zeros off. Okay, so we're falling. And then we can add a little bit of lift in. Okay, so it's stopping falling. We're moving forward again. We're going up. And then we should go back down before we reach the end and crash off screen. So obviously there's a lot that we can we sort of tinker around with the numbers to sort of like make it look exactly appropriate, but I think we got the gist of it here. So we have a simulation of plane that gets a drag based upon whether or not it's tilted backwards or forwards. Now, there's a lot to make it more realistic. For example, I'm not calculating our drag force based upon the angle of the wing into the wind. That could be interesting to do, but this is more of just like the drag that's perpendicular in case it's angled in the right way. Maybe I don't actually know how drag and plane wings work, but for the purpose of the exercise, I think we have that set. So thank you so much for watching, and I'll see you in the next video. Bye.